Good morning or afternoon, depending when you're watching this. It's Friday. Woo! Super exciting. All right, we're going to be talking about some space systems, which is a totally new unit for us. Whoa! Obviously, we're only going to get a jump start before we head off for break for a little bit. So, obviously, we're going to start with some notes. We're going to be doing space. So, that's the Earth, stars, and moon. Those are the places we're really going to be focusing on. So, let's get started. Maybe. There we go. I better move my head. It's always in the way every time. All right. First, we're going to talk about gravity. Gravity is probably a review for us. We just know it's an attraction between two objects, and the force of gravity is affected by the mass of the objects as well as the distance between them. So if they're heavier and they're closer together, it's going to be stronger. It decreases when it has less of a mass or if the objects are further apart. So you can think of like the gravity between, let's say, Earth and the sun is pretty intense. But as we go further out in our solar system, like our poor ex planet Pluto and the Earth, there's less gravity there because the distance is a lot further. And this one, you probably will have to pause and stop to take your notes, which is totally fine because I'll never know it's even happening. So just stop me from talking and moving on. Finish writing this in your notebook. Keep going. All right. There it is again. Just always in the way. Thanks, head. The second one is orbit. And so when we talk about something orbiting, especially in this unit, we're going to be talking about either the Earth orbiting the sun or our moon orbiting us. So basically, it's when an object goes around another object. And I'm sure we've all seen examples of this. I put this up, so it's just moving around the sun. All right. Our next one is inertia. So it kind of goes hand in hand with our laws of motion. So if you've ever heard of an object at rest tends to stay at rest, and an object in motion tends to stay at motion, that's basically inertia. It's just if a moving object wants to keep moving in the same spot. There's things that can slow it down. We've talked about, friction and things like that. But in this case, we're going to be talking about the inertia of planets. So if gravity was the only force, it would actually be pulled into the sun. Like the Earth would just be like right into the sun. But because of inertia, we do that orbit. So thanks to inertia, I like not being in the sun's vicinity, just, next to it a little bit. All right. Oh, no, there's my head again. Okay. So oh geez, my goodness. All right, must be a Friday or something, right? All right. The next one we're going to talk about is revolution. And revolution is a little bit different because revolution is a complete trip around the sun. So we know that one full trip around the sun for Earth is our year. So it's about 365 days. Now it's a little bit more than that. And so that's why we have a leap day every 4 years to make up for it. So it's actually 365 and 1/4 days. But we make up for it with that leap day. So thanks, February, for extending your time for us. The other planets, their revolutions can take a lot longer. So, or shorter, depending on where they are in, reference to the sun. So for Mercury, it only takes about 88 days for their year. Mars takes 2 years, and Neptune is 165 years. Can you imagine? We wouldn't even make it one full revolution on Neptune. And for other reasons we wouldn't survive, but we won't get into that right now. All right, next we're going to talk about rotation. Oh, look, it's spinning. Oh, technology. It's fantastic. Basically, the rotation is just the complete spin on the axis. Obviously, we do this once 24 hours. That's how we get our night and day because it's moving away or towards the sun. So, or keep going. And we are spinning in a circle and it goes pretty fast. It's about 1,600 kilometers per hour. So If it were just to stop, it would kind of mess us all up. So we're moving pretty quickly. We just don't notice it because it's always been moving like that for us. So that's rotation. Ooh. We'll also use the word sphere during this unit, so it's good for you to know. It's just a three-dimensional object shaped like a ball. So any one of those shapes we're going to refer to as a sphere. So we refer to Earth as a sphere. And in a sphere, every point on the surface is the same distance to the center. So this is kind of a representation of that. So, yep, that is what sphere means when we read about it later on this unit. All right, we're also going to review the moon phases. So for this one, I'm not going to make you write anything because we're going to actually have our own moon phases in an interactive notebook activity later next week. So we have basically it goes through different phases, and we'll talk about how that happens in a little bit. So these are all the different moon phases. So we're all familiar with a full moon, right? Before that, we call it different things. So it's the waxing gibbous, the first quarter, the waxing crescent, the new moon, the waning crescent, the third quarter, and the waning gibbous. We're also going to be keeping track of this. We are going to make a graph so we can see that full phase, all the phases of the moon. It's pretty interesting to see how it rotates, and then you guys will really know when full moons are. So when we get back, we'll go ahead and start that. Oh my goodness, I don't know if my head can fit anywhere on here. Okay, so next we have lunar cycle, and our lunar cycle just basically describes the process of the moon phases. So half of the moon and half of the earth are lit up by the sun at all times. And this is just based on where they are. So that's just how it is all the time. And we'll put this in our interactive notebook too. So hopefully that will make it a little bit more clear. The moon's appearance of phase changes as it orbits Earth because we're orbiting the sun. We cannot always see the half of the moon that is lit. So basically, because we're moving and it's blocking out part of the moon, we aren't able to see the moon sometimes. Does that mean it's gone and it's not there? No, it just means that it's not lit up by the sun. So if you've ever looked up and you are on something like that new moon, let's see if we can go back real quick. That new moon, it's not because the moon disappeared, which I'm sure you're all well aware of. It's just because it's not lit up by the sun. So there are going to be points where we're going to see different parts of the sun, or different parts of the sun, different parts of the moon, depending on where we are on Earth, as well as how we're orbiting the sun. So, crazy. And I know that sounds kind of complicated, and I promise it will become clearer when we do our interactive notebook. So don't you worry. All right, guys, I think we have one more. Let's see. Oh my goodness. All right. So this is going to be our last one for today. And seasons can be a little bit confusing as well. So we are going to watch lots of videos and we're going to do lots of discussion, and we'll even have a hands-on activity to kind of show you how seasons work. So they basically occur because the way the Earth is tilted. So depending on what hemisphere you live in and what your relation to the sun is whether it's summer or winter or fall or spring. Okay? So basically, if we are pointed towards, so the North Pole tilts towards the sun, then that's going to be us. So we live in the northern hemisphere. So we're going to be having summer if the North Pole is tilting towards the sun. The opposite is true for the southern hemisphere. So if the South Pole is tilted towards the sun, oh my goodness, tilted towards the sun, then they're going to be having summer, which would obviously make us be having what? I'm sure you all said winter. I can feel it that you definitely just did that. So thank you. I appreciate all the interaction that you're giving me right now. So thumbs up. So basically the same goes for the spring and fall. When it's spring for us, it's going to be fall for the southern hemisphere, and then opposite for the northern hemisphere. So we just kind of switch off. So, whew, that was a lot, especially for a Friday. But that's all right. You guys did fantastic. I'm sure you got it all written down in your notebooks, so you'll be ready to go on Monday. All right, kiddos, you have a fantastic Friday, a wonderful weekend, and I'll see you Monday. Or you'll see me. Either way, it's going to be great. Bye.